Okay, algebra students, I hope that your listening ears are on, your hands are ready to write, because we are going to dive into finding the equation for these lines of fit, right? These trend lines. And this is going to really require your prior knowledge from lesson 2.2 on point slope form. All right. Here we go. So it says, what trend line models the data in this scatter plot? So this is the definition of a trend line, right? So it says the trend line models data in a scatter plot by showing the general direction, right? This idea of the general direction. A trend line fits the data as closely as possible, right? So here is my data. You can tell that it's a positive association. So what we have to do here is we have to kind of visualize a line going through this data. Now, I did this ahead of time, okay? But I'm going to visualize that this point here, let me use blue, right? And I use this point up here, right? If I connect those two as best I can, that's the trend line I chose. Because if you look here, it goes through a dot, you got a couple dots above, 3 dots below, so that's kind of good. But the reason I use 2 points is because to find the equation of this trend line, again, this is the trend line, I need to use 2 points to find its equation. So this point right there, that blue dot, is 250. Again, I'm counting by 2's and 50. 2's on my x, 50 on my y's. And this point right here is 16,500. This is 500 up here. So once you identify your 2 points, now we're going to go to town, right? So we're going to start by using the slope formula. So m equals y2 minus y1 over x2 minus x1. Let's let 250 be x1, y1. Let's let 16,500 be x2, y2. Plug in your numbers. 500 minus 50 over 16 minus 2. That's 450 over 14. And we're going to divide and round. When you divide 450 by 14, you get 31.14, or 32.14. They round to the nearest tenth, which is 1 decimal, so we'll do the same. So our slope is 32.1. Okay? So there we go. If you're thinking about what that represents, that is the number of hybrid cars in thousands sold per year after 2000. So you can see that the electric car, the hybrid car market is increasing, right? There weren't very many around the year 2000, but now there are quite a few on the roads. Everybody's trying to get a hybrid car, right? Especially those SUVs. So now we're going to use what's called point slope form. Y minus y1 equals m parentheses x minus x1. We're going to put it in a point slope form and then put it into, or rewrite it in slope intercept form. So I need the slope, which is what I have here, and a point. I'm going to pick this point because they're smaller numbers. They will be my x1 and my y1. So y minus 50 equals 32.1 times x minus 2. I will distribute my 32.1, so y minus 50 equals 32.1x minus, and this is 64.2, and then I will add 50 to both sides to get y by itself. And I get y equals 32.1x minus 14.2. And this is your equation for your line of best fit, the one I have here to model that. Now, it is possible that your line of best fits equation would be different than mine, because you might draw it differently. You might identify 2 different points on that line. So again, I'm hoping that when you do your practice assignment, there's a threshold, right? There's values for which your slope can be in between, and your y-intercept can be in between. Okay? There you go. All right, and let's do one more of these, because they are kind of involved. So here we go. It says the table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? Okay. So I am still, Mr. Grandpa. I think my internet speed is 20. megabytes per second, right? And I just use it because it works fine for our family. But I know like the standard now is 100 megabytes. But the idea is that as your number of megabytes increases, your download speed should decrease. I'm sorry, the download time should decrease. The time to download should decrease, right? So what we're going to do is we're going to draw this graph. On the x-axis, we're going to put the internet speed, right? This is my x. So that is my independent variable. That is what I'm allowed to change, the internet speed. And that is in kilobytes per second, KB per S. And on the y-axis, it's our time to download. Again, I can't turn my paper sideways, so time to download. And that is in minutes. And it's time to download 100 megabytes, but it's fine. So if you notice here, our graph doesn't necessarily start at zeros, right? The lowest x value is 36. The lowest y value is 3.88. So what I'm going to do is I'm going to do this thing. It looks like it's a zigzag, but what it is, it's an axis break. So that means this is not going to be 0, 0. We're going to start somewhere else. And for this case, because I just need 35 to 60, I'm going to start at 30 here and count by 5. So 30, 35, 40, 45, 50, 55, 60, 65, 70. That's all I need. I'll do the same thing here on the y-axis. So it looks like 3 to 6. So maybe if I have 3, 3.54, 4.55, 5.56, 6.57, right? So that's all I need. Again, if you started at 0, you'd run out. So use the numbers they give you and just focus on that part of the graph. Okay, and now we're going to graph our data. All right, so 35, 6.65, so 35, 6.6 is more than 6.5, so right around there. 40, 5.8 is just shy of 6. 45, 5.17. 50, 4.65. 55, 4.23. And 60, 3.88. Right? And you can see this negative association, right? As the internet speed increases, the time to download decreases, right? So now we're going to draw our trend line through that data. So again, I've done this ahead of time. So the points I used were this point right here and this point 65.3 right here. And I drew, and again, this is hard for me to draw this way, so I'll do my best. Ooh, that's pretty good. It's a little wonky, but that's okay. There. Now, if you use points that are already there, that's fine, okay? But again, I think I tried to have these ones as close. You have a point above, point below, point below. Again, that's my best idea. So again, I used this point right here, which was, 40. This point right here, which was 46. And then I use this point right here, which was 65.3. And now I'm going to find the equation of this line. Okay. We do have a second part to this problem that I'll get to. It's the last part, and we'll talk about that in a second. Okay, so let's draw. No, I'm sorry. Let's find the slope. So y2 minus y1. So let this be x1, y1. Let this be x2, y2. 3 minus 6. That's my y's. 65 minus 40. I got negative 3 over 25. And negative 3 divided by 25 is a nice even negative 0.12. Great, no rounding necessary. And now let's use our point slope form, y minus. I'm going to use the 40 and 6 as my x1, y1. It doesn't really matter. So y minus 6 equals negative 0.12 x minus 40. I'm going to distribute the negative 0.12. So y minus 6 equals negative 0.12 x. And then negative 0.12 times negative 40 is positive 4.8. And then I'll add 6 to both sides to get y all by itself. And my y equals negative 0.12x plus 10.8. Okay, so there is my generic equation for my trend line. And now this second part, I'm going to use purple. Feel like in a purple mood. So it says, how long would it take to download? How long would it take to download a 100 megabit file if the internet speed, if the speed is 75 kilobytes per second. What they're saying is, they're saying that x is 75, what is y? So we're going to take this 75 and put it right in place of x right there. Y equals negative 0.12 times 75 plus 10.8. And you would just type this all into Desmos at once. And when you type it in all at once, you get roughly 1 point. I have 1.80. That's interesting. Let me double check real fast. Negative 0.12 times 75 plus 10.8. So 1.8. Right? If you put the 0, it's fine. It doesn't matter. So 1.8 seconds. I think I put the 0 because they all have 2 decimals. So I'm going to sneak it in. So 1.80 seconds. Now, if you look at our trend line, right, where is 75? 75 is right here. Notice that 1.8 is not on our y-axis. It's somewhere in here. So if we kept this trend line going, right, here's, and again, I'll try to use green, here's where 75 would be. So if you go over to your y-axis, notice that this would be 2 if we kept counting. So 1.8 would be right around there, which makes sense, right? So it falls on my line. So there's your visual idea of this answer. Okay? So again, I know that was a lot to take on, but again, this is what we care about. Can you create the trend line equation? All right? So thanks for watching. Best of luck on your practice.